It's an honor to be here and share this forum with these amazing CLA faculty. Yes, I'm Michael Ponte, an associate professor in the Department of Anthropology and Geography. And I'm not going to talk to you about the research that I was acknowledged for today. I'm going to tell you about what I'm doing now and in the future. And that is to study cannibalism. That's why my talk is entitled, Guess Who's for Dinner? So cannibalism is, of course, when an individual consumes a member of its own species. That is difficult to identify archaeologically for two reasons. One, many things can scratch a bone, and it looks like a cut mark. So we're not that great at identifying cut marks, and we make mistakes. The other is cut marks alone do not prove consumption. So we need more information than that. This skull here is 600,000 years old. It's from Ethiopia. It has cut marks all over it, but we can't prove it was consumed. I think the one thing that comes up when you start talking about cannibalism is why would anyone do this? It doesn't make sense to us, right? It could be for nutrition, it could be for survival, but most often we infer that it is part of some ritual mortuary practice. So here, this is potentially the first cut-marked human ancestor. It dates to as old as 2.6 million years old. But the scratch here, you can see, this is on a cranium fragment. I can tell you this is not a cut mark, and maybe you can ask me why after. The earliest evidence of cannibalism, on the other hand, comes from a site in Spain that's about 800,000 years old. And there we have several individuals that have been cut, but also bones processed for marrow. And that's important because the only reason to do that is for consumption. So that brings me to today's talk, which I'm going to cover two research projects I'm working on. One of the earliest cut-marked human ancestors that I studied, and also a site from 130,000 years ago in Croatia where Neanderthals were cutting each other up for some reason. Was it cannibalism or a ritual? That is the question. So here you can see a leg bone of a human ancestor. It was discovered in 1970 by Mary Leakey and put in a museum. My colleague, Brianna Pobiner, from the Smithsonian Institution, she was studying all the human fossils in the museum, and what she noticed was there's scratches on this bone that look like they could be cut marks. And in the past, we would say, I'm an expert, that's a cut mark, so believe me. And she realized that's not enough. So she knew I developed a novel method here at CSU that uses quantitative methods and machine learning to classify marks using computers, so we could be more confident in the identifications. And what that looks like is here. So Brianna found these marks. She took an impression of the surface, and she mailed it to me without any information. And she's like, well, what are these marks? And I made 3D models of them, which you can see here. And then what I did is compare them with nearly 1,000 individual data points of marks made by things in modern times. So how do we get those marks? We butcher animals, we break their bones for consumption. We feed them to lions and hyenas and things like that. And we also have cows step on bones because that looks strangely like a cut mark. So you can see here all the dots. These are the individual marks from the fossils. And what we learned were 9 of them were identified as cut marks. And 2 of them were identified as tooth marks, most likely from a lion. So what can we say from this? We can't really say if it was consumption or not. The marks themselves are basically here where your calf is. So there's meat there, but we don't know it was eaten. That didn't stop the press from sensationalizing the results and saying we were carving each other up for dinner and even killing each other. Of course, we didn't say any of that. That brings me to the second study, this rock shelter in Croatia. It's an incredible assemblage of Neanderthal remains, and it's been argued about since it was discovered in 1900 whether it's evidence of cannibalism or symbolic ritual. You can see here the first piece of evidence I'm going to show you. These are the bones from the body, and these are the bones from the head in the collection. There's over 700 of them, and they are broken up. And what that tells me is this is a way humans process animal bones for food, okay? So it's very similar. The other thing is there's no way these were buried as complete skeletons, okay? The main evidence for symbolic behavior at this site comes from this individual skull. You can see these lines. They are cut marks that make not much sense anatomically because they are in a position where there's no meat and you wouldn't have to cut there to scalp an individual. But when you take a step back and you look at all the fragments from the skull and every single cut mark that we observed by studying the collection, we can see that most of the cut marks are in places where there's muscles, or you would have to cut to scalp someone, or if you wanted to remove the tongue, like you can see there. So that evidence becomes less strong for symbolic behavior. We can also look at the limb bones in the assemblage for information. So this piece of a tibia has not only cut marks on it, but also tooth marks. And those tooth marks are very similar to what we know modern human tooth marks to look like on bones. What does that tell us? This is possibly direct evidence of Neanderthals chewing on the bone. Beyond that, we also have impact marks shown here. This bone is split. This is what our ancestors do to break the bones to get marrow. And we split them longitudinally because it makes it easier to get the marrow out. This is very strong evidence for consumption at the site. Finally, this is a bone that was chewed on by carnivores, a human ulna, your lower arm bone, and we can tell by the conical pits and missing ends. And this tells me these individuals were discarded after consumption by the Neanderthals and never buried. So strong evidence that they never were part of possibly a ritual, but they were being left behind. So to conclude, if we use these novel methods of analysis, we can be much more confident in our identifications of cut marks on fossil specimens. So thank you very much.